GATE 2016 Civil Engineering Set 2 Question 53. The critical flow ratios for a three-phase signal are found to be 0.3, 0.25 and 0.25. The total time lost in the cycle is 10 seconds. Pedestrian crossings at this junction are not significant. The respective green times expressed in seconds and rounded off to the nearest integer for the three phases are. Four options have been provided. The relevant NPTEL reference is cited. Coming to the useful data, one needs to know about the Webster's method for designing a signal. As per the Webster's method, the cycle length is given by 1.5 times L plus 5 divided by 1 minus the summation of the critical flow ratios. Here L is the total lost time in the cycle. This is taken in units of seconds, and YC is the critical flow ratios for each phase, and these flow ratios should be added together to form summation YC. C is the cycle time in seconds. Once the cycle time is known, we can find the individual green times using the formula Yi divided by summation Yi into C minus L. Here I can be taken as 1 since we are talking about the first phase. This is done because we subtract the total lost time from the cycle time, so this is kind of the efficient time of the cycle that is used, and this is split in the different phases in the ratios of their critical flow ratio. So in this question we have been given the total lost time as 10 seconds and the critical flow ratios are given as 0.3, 0.25 and the third one is also 0.25. So firstly we will need to find the cycle length as per the Webster's method. So that will be 1.5 L plus 5 divided by 1 minus summation of the critical flow ratios. This would turn out to be 1.5 into 10 plus 5 divided by 1 minus the summation of 0.3, 0.25 and 0.25, which are the critical flow ratios. This would become 20 divided by 1 minus 0.8, which would turn out to be 100 seconds as the total cycle time. Now we need the individual green times, that are G1, G2 and G3. So G1 would be Y1 by summation Y into C minus L. So this would be 0.3 divided by summation Y, that is 0.8, into cycle time, that is 100 minus 10. So this would turn out to be 3 by 8 into 90, which is 33.75 seconds. So the question instructs to find the green times rounded off to the nearest integer. So this can be rounded off to 34 seconds. G2 would be Y2 by summation Y into C minus L. So Y2 is 0.25, summation of Y is 0.8 into 100 minus 10. This would turn out to be 28.125 seconds. This can be rounded off to the nearest integer, that would be 28 seconds. G3 will be Y3 by summation Y into C minus L. Y3 is also 0.25 divided by 0.8 into the C minus L, that is 90. This would also become 28 seconds since it is the same as G2. So the green times were found out as 34, 28 and 28 for the three phases. So the respective green times for the three phases are, which were rounded off to the nearest integer, 34, 28 and 28, which is option A. The relevant NPTEL reference has been mentioned.